All right, so we have your test to get back today, but we want to do the lesson really quickly first. So then I can take whatever questions, and if you guys don't have test questions, and you can work on your homework while we go over that. So homework tonight, this was yesterday, but in case you only did 3. Now, your questions don't have to be in order. So last night, if you did 3 from 715 and 3 from 716, just go back and do a few more. They can be on the same page. And really, I'm not saying you specifically have to have, that's like maybe 12 problems done. Just make sure you do at least like 9 or 10. Just get some good practice in. And again, like, focus on the ones that make you nervous. Like, when you look at a problem, you're like, oh, I don't like that kind of problem. Focus on that. The reason you don't like it is you haven't practiced it enough, most likely. All right, so yesterday we started talking about the fraction buster method, right? Like, right at the end of class. Can anyone remind me what we could do to Sherry's equation here? And Kevin, I believe, told us yesterday. What could Sherry do to her equation to make this, like, loads easier? Don't make me go back to Kevin. I want somebody new. See who's paying attention. Brendan? Why could we multiply by 3? Yeah, then it'd all be whole numbers. It would be 2x plus 4 equals 10. So similarly, I'm going to lift this up so I can stop sitting down and... Oh, that's interesting. Similarly, with this next problem, I believe we started looking at this yesterday, right? And it's what's on my chalkboard. We went ahead and said, well, if we're working with fractions, we might as well make 7 a fraction. So if you don't have this written down, please go ahead and write it down again, or you might just want to write it down again for practice. We talked about this yesterday. How can we destroy the division by 4 at the same time as the division by 6? Sorry, everything seems like you got it at a weird angle, so I'm trying to fix stuff over here. How would we, if it was just division by 4? Or you can give me everything. Multiply by 24, because that's going to multiply by 6 and multiply by 4 at the same time. Now, guys, I'm going to flip my screens and show this both ways. Please write out both ways with me. Often this doesn't make sense quite at first, but hopefully you'll have that light bulb moment if you're writing things out with me and like you let yourself have time to make this make sense. So real quick, cut this out. So Ethan said multiply by 24. So let's go ahead and write down multiplication by 24 on both sides. Now this is going to be the way where I just show out all of the work. So this would then become 24x, 4. Break that up, becomes 120. Break this up, 140, 28, 160. Even if you had it yesterday, it would benefit you to write it down again. I'm going to steal at least one of these. Probably this one. Then we reduce, right? What's 24 divided by 4? 6x. Forget about the 0 for a minute. 12 divided by 6? 2. Put the 0 back on. Please write that down. Then, what would we do on both sides? Ooh. Add 20. Careful, a couple of you guys switched those around on the mastery where we were supposed to add. Maybe you subtracted by accident. Sorry, 148. What's the last thing we need to do here? Yeah, divide by 6.
188. 188.
Good catch. Yeah, no. I have started to like run out, which is the idea, because by April I really don't need it. We'll buy more stuff for the Columbus trips and everything. But yeah, no. What? Snacks and yeah, all sorts of stuff. snacks, candy, whatever. I mean, we do minute to win it things that have prizes like every day. There's a lot of fun that you don't know about yet, but I can't talk more about it if we don't have enough time. Even for class today, what do you get? 188 divided by 6. What? 31.3 repeating. Or 31 and a third. Now, I'm going to do this the completely other way. That is faster, easier, but you have to pay attention to what you're doing. Okay? Do me a favor and put your pencil down. If you have this all written down, put your pencil down. Listen and let your brain process. You don't even have to write down the second version if you don't want. We'll do it on another problem. So if I go to do this again, but instead of just thinking about multiplying by 24, I'm actually going to think about the fact that I'm going to multiply by 6 and multiply by 4 separately. And we talked really briefly about this yesterday, but it was the end of class and we were all stopping, paying attention. So we said we want to multiply by 4 and 6, which is why we multiply by 24. So over here we know we get 168. There's no other way to do that, right? You just 7 times 24. When I go to do the multiplication with my x over 4, the multiplication by 4 doesn't need to happen if I pair it up with the division by 4 and say, what's 4 over 4? 1. So really, this is just going to multiply by 6. And this becomes 6x. I should have captured the last way we solved it. When we go to do the multiplication with the 5, 6, and I've got my minus down here already, the 6 on top and the 6 on bottom cancel each other out or reduce out to 1. So I really just multiply by 4, and we get 20. Negative 20, of course, but notice how this is the next step that you guys just had written down on your paper. This is doing the reducing while you multiply, as opposed to multiply and then reduce. But guess what? It doesn't matter which way you take. So if this way is complicated for you right now, and you're like, wait, why? How is that? Just do the multiplications and then reduce. But if this makes sense to you, how we can break the multiplication out and only do one piece of it, you can shortcut yourself. Cool? Questions? Actually, let's do one more like this, and then we'll take questions. And this method is called the fraction buster method. I think we wrote that down on your papers yesterday. But when CPM asks you to apply the fraction buster method, that's what they're asking for. So if you need a reminder of how to do this, look up fraction busters in your book. So write down 2b over 3 minus 1/6 equals b over 2. On your own, whichever method makes sense to you, apply our fraction buster method. You either take the shortcut fraction buster or the full length fraction buster where you do all of the multiplications and then reduce. I'm actually going to probably copy this and do both. What should we be multiplying by on both sides? What number are we going to multiply by on both sides? We don't need to go to 18. Don't need to go to 12. Just 6. Because, guys, 6 would get rid of this. It would also get rid of this, and it would also get rid of this. Now, you could multiply by something bigger, but we don't need to. We could just multiply by 6. Try to solve this on your own. Don't look up here unless you're stuck.
Good morning, Kimberly Ball. Please come to the office. Kimberly Ball to the office, please. Thank you.
Now guys, for a while, it might be easiest for you to take the method on the left side because there's no special circumstances happening on the left side. I decide, what should I multiply by? And you could have multiplied by 18. Those of you who said 18. You could have multiplied by 36 if you wanted to, because 6 times 2 times 3, if I multiply all of my denominators together, but 6 is 3 times 2. So I can destroy the 6 at the same time as I destroyed the 3 and the 2. So 18 would have also worked, so would have 24, but then I just multiply in the numerators, right? So, because that's numerator, that's so 6 times 2b, 12b, the 3 comes down. 6 times 1, 6 comes down. 6 times b, okay, sweet. Questions getting to this step. Then we reduce. Questions getting to here. The right side does it all at the same time. So I tried to color code what's going on here. The 3's reduce to 1 and the 2 still multiplies. 4b. Same thing we got over there. The 3 and the 2 are needed to reduce the 6. We get 1. And over here, the 2's reduce out, and the 3 multiplies. We get 3b. Same thing we got there. Questions on either of these. You choose which method makes sense in your brain and which way you want to take it. Either way works. Then we would just finish out the solution. So, what could I do on both sides here? Yeah, we could add 1, but then that's still going to leave me with a mixed side. It's not as nice as I wish it was, but we could take away 4b. And that would leave us with -1 equal to -4b. Or, sorry, -1b, my bad. I just wrote the same thing twice. -4b and then another -4b. So what does that mean b is? What times -1 makes -1? 1. Right? B has to be 1. Even if we divide here, a number divided by itself has to be 1. B is 1. Questions? Yes.
Okay, I have no idea how to do this. Like, should this be like making sense?
Yes. So, the other longer but simpler way to think about fraction busting. Okay, you got to write things down and stick with me, you promise? Yeah. Write down the equation again. That same equation. 2b minus 1/6. And if any of you are struggling, Ava just has really good confidence. to ask questions.
No, I only did because Aiden's struggling too.
Good. Not good that you're struggling, but good that you asked the question. We're trying to get rid of every division at the same time. Because if I had all day in the world, and if you were getting paid by the minute, and you wanted this to take forever, multiply by 3 on both sides through everything. Then multiply by 6 on both sides through everything. Then multiply by 3 on both sides. But you multiply by all of the divisions, right? So you'd have to multiply by 3 and 6 and 2. We can do that all together by thinking, what is 3 times 6 times 2? All of the denominators put together. Well, that's 12 times 3, 36, right? So if we multiply by 36, that is the product of all of the denominators. So essentially you could make a note in your notes of you multiply the denominators, and that's how you decide what to multiply by. We're multiplying by all of the denominators. And we can do it all together. Any questions on how I got my 36? This is yet another way to do this. Then, just multiply. Tops to tops, bottoms to bottoms. So 36 times 2, 72b over 3. Minus 36 over 6, 36b over 2. This is why I don't like using b. B's look like 6s.
Yeah.
So guys, I see some people totally not writing with me. I'm hoping that you got it. Like you've already mastered this. I'm scared that we just started this yesterday. So if you're not working with us, you're essentially communicating that you're ready for the mastery. Like you're ready to show mastery of this skill set. Now we can reduce, and if we've done the fraction busting correctly, all of these will turn to integers, right? No fractions. 72 divided by 3 should turn into a whole number. Well, break it. What's 60 divided by 3? 20. Then 12 divided by 3? 24b. Right? That's what 72 divided by 3 is when we reduce it. 36 divided by 6? 36 divided by 2? 18. What do we do on both sides, class? Yeah, if we want to make things positive, we'll take the positive route to make things really nice here. Now what can we do to get the b's together? And honestly, when I give you your masteries back here in just a moment, if you didn't master your mastery with equation solving and everything, you should always be writing down our equation solving methods. Like, I've been teaching long enough, I've now realized that like me fighting you about it doesn't do any good. You need to be honest with yourself. You either know that you know how to do this, or you know that you don't know how to do this. If you aren't completely comfortable, you should be writing down everything. What times 6 will equal 6? 1. Same answer. Completely different way to get there, because we used a completely different number from the get-go. We still get the same answer. So, does that make any more sense, Ava?
Yeah. No.
So we took all the denominators. I appreciate you being honest with me.
Like,
You
I
take-
understand that you have to take all the denominators and you're trying to get, like, a positive number.
Not necessarily positive, just whole numbers.
Okay,
No
but
fractions.
Number, same thing. Just, like, get...
Here, help me out. Let's go to 67 real quick. I just want to check, because I need to give you your test back. I just want to check if we can determine what to multiply by. Then you guys need to practice these over the weekend and come back on Monday and let me know if we like understand it after we practice it on our own, or if we need to do more classwork. But I need to get your test back, and I need to do that by 30. When we look at 67A, all I care about is identifying what should we multiply by here. So take a moment, and you should go ahead and write this down so you have examples on your paper. Our one denominator, apparently Smart Ink isn't going to work for me today. I'm going to copy this out real quick. Go ahead and write down all three of those if you want, because then we'll just go through them real fast. We're not going to try to overthink these. We're not even going to try to shortcut these. We're going to do the longest method, which would be easiest, but it will always work out. Not demin, but denom. Our denominators are 6, 4, and 3. So all combined together,
72.
whatever the product of your denominators, that will be your multiplier. So when we look at part B, 6, 12, 8. So I told you, we're not taking the shortcut way. There are shorter ways that we could take this. Now, that's huge, right? So back yourself down. Here's where we have 2 minutes that I want to get through the rest of this. All we're looking for is a common multiple. Give me your eyes real quick. Put your pencils down. Here's what we're actually thinking. Multiples, multiples, multiples. I can write out multiples all day long.
It's 1,000.
Or I missed 36. Yeah. And then 8, 16, 24, 32, 40. What we're thinking through is what number is a multiple of all of these. So the easiest way to find that is multiply them all together. It'll always work. But the smaller number and easier math, honestly, is to think of their multiple lists and find what one is in all of them. 24. So here, we could multiply by the product of all of them, but the better choice, crap, put those in the wrong place, is 24. So we could do 24 on both sides, and that's the smaller number. Or, Aiden, what'd you say 8 times 12 times 6 was? 576. This would also work. Either of them would work. We can do anything we want as long as we do it to both sides. So, Ava, if it's not making sense to get these, just multiply all of them together and use that number. But you're going to be working with really big numbers then. If you want to work with smaller numbers, list out their multiples and find a common multiple. This is a common multiple. It's just not the smallest common multiple that we have here. So then we think of common multiples, because if I multiply 15, 9, 5, and 3, I'm going to have a giant number. But if I think about common multiples, 5, 15, 9. 9 is probably going to be my weirdest one to work with. So 9, 18, 27, 36, 45, 54. 9's probably my weirdest number here, right? Because 3 has a bunch of multiples, 5 has a bunch of multiples. 15, it's nice because it is the multiple of 3 and 5. 45, guys, would be a multiple in all of these. 3 will multiply up to 45 if I list them out. 5 will multiply up to 45. 15, 15, 30, 45. Yeah, 45 is our lowest common multiple here. Now, alternatively, 3 times 5 times 15 times 9, well, ignore the 15 because, guys, you already get 15 when you do 3 times 5. So if you do 15 times 9, we get 90 plus another 45, 135. So 135 would work. But an easier option would be 45. Practice this over the weekend. Be ready for a potential mini mastery on any day next week. Okay? Now we got to talk about your masteries from last week. Yeah, right. I probably did. Yeah. Because I knew what I was going to. I forgot 36, but then I wrote it below the... And my smartboard is goofed. Done goofed. Can't get it. Yeah, you're probably right, but my smartboard. I know. It's because the right side of it gets screwed up. It's like not oriented right, so the right side like pulls to the off the screen. Put your eyes on your problems to figure out what you missed and why you missed it. Now, some of you had hey guys, I'd give you a few seconds of like me being patient. But when you're still talking 5 or 10 or 20 seconds after the teacher in the room or the person who you're supposed to be focusing on has started talking, you're just being really rude. What you're saying is, I'm more important than you. I don't care to listen to you. And if you raise your hand and get like recognized, I would love to listen to you. You are more important than me. But you're essentially paying me your parents' taxes to try to help you with math. So I would love if when I'm talking, you listen. We're going to go over the main missed problems. You, if you're progressing, need to first correct it. Then, depending on those corrections and how much you had missed the first time around, there might be another supplemental activity. So your first task is just correct your test. Now, if you're mastered, I already have that written down. You're good. So if you're mastered, you're good to keep it out right now, because you probably still made a mistake. I don't think there was anyone who had a perfect test. There were a couple people who only made one mistake. You guys keep me on my toes and move seats. And then you're all staring at me, waiting, and it just makes me nervous. Because I look up to find you, and it's like 8 sets of eyes burning into my face. All right, so I'm going to use the dot camera here, so take a moment to just look yours over while I get the dot camera pulled up. Yeah, so if you have like an NF/P, just finish the problems you don't have finished. If you have an NP, what I'm really trying to communicate with that is I don't feel like you have practiced. That does, okay, so this goes back to the whole Phoenix brainwashing thing.
Can I please have Olivia do dash to the office? Olivia?
NP, what does NP directly translate as? Not progressing. That doesn't mean you suck. It means I don't think you're progressing. I don't think you're growing. We need to fix this. We need to figure out what's going on. So guys, there's a few people in my Comp 7-8 class, my like accelerated class. I gave out NPs in that class more than I gave in Math 7. Because some people straight up didn't learn scientific notation. What the heck, guys? We did 3 days on this. It's okay. It's just my honest feedback. I don't think you are progressing. We need to fix this. So, as you all saw, it's all just needs to see me for mastery. If you have a see me for mastery, do that either today if you get a chance. I just grabbed your test so we can look at these problems. Guys, number 2, if I'm being honest, I got real mad when I had test blank on number 2 after having multiple days to do this assessment and me giving you a post-it to write down anything you didn't know on. This was the easiest opportunity for you to go look up what is boundary point. And some of you still turned it in blank. I'm not going to go over what a boundary point is. If you still don't know, you need to look it up or you need to discuss it with your friends. On 4 and 5, some of us weren't quite clear that we're trying to solve and then graph. So I think we're probably more comfortable with it now that we've been going through chapter 7. But your graph is not going to use 1 as the point on the graph that you talk about. You have to solve to isolate A, get it all by itself, then the number on the other side is going to be the number on the graph that we use. Okay, we have to solve out. In B and C, guys, some of you got it to 2m or 3x. You isolated the variable term, but you still had a number in front of it. Keep going. And I wrote that on your paper. Keep going. You got to get it to 1m or 1x or 1t or 1k. I don't want to know what 9k is. I want to know what 1k is. Right? We want to solve for what the variable is. I think most of us got 6 because it was more of a visual problem. On 7, look at that real quick. This print came out really crappy. Sorry, and I wish somebody had asked about it during the test. That should have been an equal sign between the 2 and the 10x, which I think a lot of you figured out. Maybe just remember, here's the in-between what we're doing on both sides. Here's the in-between what we're doing on both sides. Results, and then final result. And I think a lot of you got right what she did wrong. But if you didn't, just go back and fix that. Just proof that I do write these tests. Chelsea's my wife. Dave's my roommate. So Dave also teaches math. So this problem, I was laughing to myself because Chelsea is always right because she's my wife. So Chelsea's right in this problem. And I think we all got that one. Let me check my answer key. I made notes for what you guys had your most mistakes on. Everyone look at your answer for number 9. Yeah, but you might not have. All because I marked it correct doesn't mean you were actually correct. Give me your attention. I don't know why people are talking. I love you. I really do. I love you guys. Like, the only reason I keep teaching, it's definitely not the money. It's because I care about you guys. But sometimes you're frustrating me. This problem, you have 2 situations to think through, and I think a lot of you stopped reading after Kyle. Because a lot of you said Kyle's right. Sure, Kyle said distribute the 6 to remove the parentheses. That'll work. But then some of you went on to say, because we cannot divide. Could I divide by 6 over here and divide by 6 over here? Mike's also right. So the only way that you are actually 100% correct on this problem is if you said that they're both right. Now, I accepted if you said Kyle was right, or if you said Mike was right, because they are. They're each individually right. But no one's wrong. They're both right.
So there's no way to get it wrong?
Well, if you said they were both wrong, really, if you only said that one of them was right and the other one was wrong, then your answer wasn't right. But if you said Kyle's right and you never said Mike was wrong, then it's, yeah, I mean, Kyle is right. But you should have investigated whether Mike was right or not. You know what I mean? Like, don't stop the problem halfway through, is really what I'm trying to get at here. In 11, I think some of us misread. It goes down by 0.3 degrees each minute. It's going to take at least 3 minutes, more than 3 minutes actually, to even lower by a single degree. And I need to go from 88 to 76. So I think some of us need to look at that again. We're really looking at what is the distance we're trying to cover, the distance in temperature, what rate are we changing at, and how much time will it take to do that? Distance, rate, and time. You can use your dirt equation here. Distance equals rate times time. 12 and 13. As I said, you didn't really need to solve using the 5D process, but you could. Be careful. A couple of you switched around their grades. Severus had the lower score. So just be careful. Lily's score was higher. And 14 was essentially seeing who has been doing their homework all year long. Guys, if I'm real honest with you, and I really hope that you have realized through this year, like, your Phoenix teachers are always going to give it to you straight. Like, if anything, we're probably too honest. We've been doing triangle area since chapter 1. It was in your homework in chapter 1. I know so because I did the homeworks for a few chapters, and then I just let Mr. Smith take that over and do the uploads. That doc is still going, by the way. Reminder, those active homework, like the homework solutions, not only are the answer keys in Schoology, but that homework solution document is one giant document that is in your parents' email they get every week. If you want to go check that out, Mr. Smith is still uploading all those solutions. The area formula for a triangle. I'll write it up here. I'll pull Smartboard back up. It's almost out of time anyways. I'm going to go through this slowly, so my apologies to anyone who, like, you know it already and you're comfortable with it. What is the formula for area of a rectangle? Base times height. So if our rectangle was this, we'd multiply the base times the height, and we'd have our rectangle area. When I think about a triangle, and this holds true for any triangle, how much of the rectangle does it occupy? Half. The formula for triangle area is 1/2 base times height. But be careful when we plug in these numbers. I forget which one was which, but one of these is twice as much as the other one before the math happens. One of these is twice as much as the other one before the half happens. Okay? So that was the end of that. We had until, I think, 46. So we have a couple minutes left. Yeah, we have until 46. So go ahead, and if you need another sheet for corrections, go ahead and get one and head it with your revisions header. And we'll just take the last few minutes for you to do whatever you need to take care of.